there are a lot of opportunities and work to be done in this space. We leak a lot of details about the Lakehouse to the customers today, right? Customers have to think about layout, file sizes, sort order, etc., so that their applications are reliable, efficient, and whatnot, right? But we want, through table services, we want to abstract many of these away from the customers, similar to how databases hide many of its internal details, right? So you just put data in, you take data out, and that is it, right? So everything else is taken care of internally. That's what we want to work towards. And at the same time, we also want to make incremental ETLs mainstream, right? So we want them to be a first-class citizen so that we unlock a lot of business opportunities. So that's on our mind, and that's what we're working towards.
So after I joined Robinhood, we built this near real-time Lakehouse platform using incremental CDC approach, using Apache Hudi as the underlying platform here, which helped us to bring the data freshness from 24 hours to 15 minutes for critical data sets. So yeah, so just to give us some numbers, like, so we have around like 2,000 tables, out of which like 5 to 10% are very critical data sets with tight SLA of 15 to 30 minutes. In Robinhood, like we not only use the Lakehouse for usual data analytics purpose, we have some critical product use cases such as brokerage clearing and statement generation and things like that. So reliability and data quality is like super critical for such pipelines. So we again, like, we use this Lakehouse for asset semantics using Apache Hudi to ingest data reliably and to power these kind of use cases. So finally, like we recently went international by supporting UK customers. So another important requirement was to bring GDPR compliance and like other regulations into the Lakehouse. So supporting data deletion is like very critical technical requirement. And again, like we built the data deletion strategy in the Lakehouse using the masking approach and Apache Hudi. Relied on that to have basically the efficient absurd capabilities to delete data.
So what do you see as a key benefit that this data lakehouse provides or enables when you compare to like a data warehouse or even older, generation of data lakes?
Just to give some glimpse on the size and scale, right? So we are hundreds of petabytes. We run like 600K plus cores to just process the data, right? So it's a massive amount of data. We have multi-cloud. We have our own private as well as we are in Azure and GCP. The retail ecosystem is where update is inevitable, whether it's a journey of an order or returns or whatever happening, we're getting continuous streams of update. First of all, it was becoming very, very difficult to manage that volume with the traditional data lake or the batch-driven data lake approach, just because of the sheer write amplification and the number of partitions it will go span across and update. Moving from there to it not just help us manage the processing of data, it definitely improve with the incremental data processing, the absurd support and so on. It reduced the processing cost for sure compared to traditional way of data lake or managing data lake. At the same time, it improved the query performance significantly for us, which also empowered like the data analyst, the data science community. They just don't need to wait for them and kind of improve time to analytics for us compared to traditional, like where you manage the data in lake and then move it on from there to warehouse. And then not just that, the schema evolves very fast, the way retail business is, right? So even that, we wanted to make sure the format or the storage layer should able to kind of capture that. And then definitely bringing the semantics up, the whole strong type, making sure we are getting ACID compliance, the caching, the partitioning, ordering, and all that. It just improved the query performance at the scale which was not possible before.